Okay, so in this video, I will be going over HiSET Math, FPT 6A, number 3, practice math problem. And in this problem, the question states, in the standard XY coordinate plane, for what value or values of x will the graphs f of x equals absolute value of x and g of x equals absolute value of x intersect? So there's a lot of different ideas going on here related to coordinate geometry and algebra. So the first thing I want to do is talk to you about the coordinate plane. So you are probably familiar with the coordinate plane. This is a plane that contains two lines, two axes. You have an x-axis and you have a y-axis. So this might be my x-axis right here. And this might be my y-axis right here. So this is a standard coordinate plane. And the coordinate plane has coordinate points that correspond to a value in x and a value in y. So for example, if I have a point located right here on my coordinate plane, that would correspond to this x value, and it would correspond to this y value. And the x-axis is just simply a numbered line. So the center location here, this is called the origin. That's 0. It's 0 on the x line, and it's 0 on the y line as well. And then I could create some little tick marks here. So maybe this is 1. And then maybe this is 2, where my point is actually located. And this might be 3. And here's 4. Okay, so this is the x-axis, and we also have tick marks in the negative direction. So this would be -1. And this might be -2. And so on. So this line would extend in both directions, kind of infinitely. And so the x value for this point is +2. And when we describe the value for a point, we use what's called a coordinate pair. So we're going to set up two parentheses. There's going to be an x value and there's going to be a y value. So the x value here is 2. And we'll separate the x and y value with a comma. So if I were to add some tick marks here on my y-axis as well, maybe this is 1. And maybe this mark here is 2. And then maybe where the point is located here, maybe that's 3. +1, +2, +3. Again, the y-axis also extends in the negative direction. So we would have -1, -2, -3, and so on. So the y value, the place where this point kind of translates or corresponds on the y-axis, is at +3. So we could use the coordinate pair 2, 3 to describe the location of this point in the coordinate plane. So this is what they're talking about in this problem when they say in the standard XY coordinate plane. We are talking here about coordinate geometry. And it's asking you, for what values of x will this graph f of x equals absolute value of x and g of x equals absolute value of x intersect? So we need to understand this idea, the graph of f of x equals absolute value of x. Now I'm saying this phrase, absolute value. Let me type that out here. So the phrase I'm saying is absolute value. And absolute value is indicated using these up and down vertical bars. So I could have a vertical bar here representing the absolute value of x. Absolute value is simply the distance that a value is from 0. So if I'm looking at my coordinate plane here, then I might notice that this number, this value 2 right here, if I think about how far away is this point, is this value of 2 from 0? How far away is 2 from 0? Well, if I were to walk, taking one step at a time, I would have to take 2 steps to get from 0 to 2, right? So the absolute value of 2 is 2. It is 2 steps away from 0. So let me just kind of indicate that here. The absolute value of 2, and that's going to be notated using these vertical bars. So I've got the absolute value of 2, and that value is equal to 2. It is 2 steps away from 0. Okay, but let's think about the negative numbers, kind of the negative side of the x-axis in the coordinate plane. So I'm looking now at this number, -2, right? So I want to know, what is the absolute value of -2? How far away is -2 from 0? Well, again, if I wanted to start at -2 and walk to 0, I would have to take 2 steps, right? If each little notch mark is a step, then that's 1. 2 steps it takes me to get to 0. So the absolute value of -2 is exactly the same as the absolute value of 2. It is also 2. So the absolute value of -2, and again, notated using these vertical bars, absolute value of -2 is also equal to 2. There's really no difference when we're talking about absolute value. Another way to think about absolute value is to think of it as the size of a number, regardless of whether it's positive or negative. So we're not concerned about the direction, whether it's in the positive direction or the negative direction. We're only thinking about the size of the number. So +2 and -2 have different directional values, but they have the same absolute value. Their size is the same, although their directional values are different. So 2 and -2 both have an absolute value of 2. All right, so when I talk about a graph, this means that I'm representing all the potential values, all the potential absolute values. Okay, so I'm just going to add kind of a new page here. Let's see. Okay, and I want to take a moment and talk about the graph of the absolute value of x. So when they talk about f of x, that value f means function. We're talking about function. So we're going to graph here, the graph, we're going to describe the graph of a function. And the function that we're going to talk about here is the function of x, f of x, such that the absolute value, we are looking at the absolute value of x. So in other words, we're going to perform a function on x, and when we do, we're going to find the absolute value of x. So we can set up kind of a column to describe all the possible values of x, and then we're going to set up another column to describe all the possible values for f of x. Okay, so we know x could be a negative number, it could be a positive number, it could be 0. It's anything on that x-axis, that x line. So let's take a couple of examples in both directions. Let's look at -2. Let's look at -1. Let's look at 0. Let's look at +1. And let's look at +2. Okay? So again, f of x equals in this case, the absolute value of x. So if x is -2, then what would the absolute value of -2 be? Well, we've already talked about that. It's the distance that -2 is from 0. So the absolute value of 2 is just 2. And when we say just 2, we're really referring to +2, okay? Because you can't take negative steps, right? You can't walk -3 steps. You can walk 3 steps in the left direction or 3 steps in the right direction, but you're walking positive number of steps. So distance is a positive value. Absolute value is a distance. So absolute value is always positive. All right, let's think about -1. How many steps away from 0 is -1? Well, looking back at our number line on the previous drawing, if I can get there, my computer's running a little slow today. But looking back at our number line on the previous drawing, we can see that if I were to start right here at -1 and I'm going to walk to 0, so I'm going to take just one step. Starting at -1, I'm taking one step to the right and I will land at 0. So the distance that -1 is from 0 is 1. So that's just going to be a positive 1. All right, what about 0? How far away from 0 is 0? Okay, that's kind of a theoretical question, right? But it's not anywhere away from 0, right? 0 is exactly on 0. If I am at 0 and I want to get to 0, how many steps am I going to take? None. I'm going to take no steps at all. So the absolute value of 0 is simply 0. All right, how about the absolute value of +1? So this time we're at the +1 value on the x-axis. We're over on the right side of 0. We're walking back towards 0. So starting at +1, walking back towards 0, I'm going to take one step. This is not a -1. Even though I'm walking backwards, I'm taking one step. It's a distance of 1 that I'll be walking. So again, that's going to be a +1. Remember, absolute value is always positive. That's an important thing to remember about absolute value. And we've already talked about the absolute value of +2 is exactly the same as the absolute value of -2. It's also 2. So you can kind of see a trend that's happening here. No matter what the value is, whether it's negative or positive, the absolute value is always going to be positive. For 0, the absolute value of 0 is 0. So I've created a table here. I've got a column for my x, a column for f of x, which is the absolute value of x. Now, how do we create a graph? Well, let's take a look at that. So we're going to, again, have an x-axis and a y-axis because the graph lives inside the coordinate plane. A graph is on the coordinate plane. So if I have an x-axis and a y-axis here, so again, this is x right here. This is y. And y is really, it's kind of the output. If you want to think of a function, has what we put into the function and then what comes out of the function. So in this case, we put in an x value and what came out was the absolute value of x. So y is really representing f of x, which is the absolute value of x. And we're going to graph these together on this grid. Okay, I cannot get that to make an equal sign. Okay, equals the absolute value of x. Okay, so we know that y is equal to f of x, which is the absolute value of x. So I'm going to kind of cheat a little bit here. Rather than trying to write all of the values, I'm just going to click here and I'm going to input those values. So remember, 0 is at the origin. 1, 2, 3, 4, 5, 6. We'll stop there. That's really all we need. And I'm also going to put some negative values over here. So we might have a -6, -5, -4, -3, -2, -1. So we've got these values along our x-axis, and then I'm also going to put some values along the y-axis. So I might have, in the positive direction, I might have 6 and 5 and 4, 3, 2, and 1. Let me just kind of translate this down a bit. There we go. All right, and then in the negative realm, I might have the opposite of that, right? So I might have -1, -2, -3, -4, -5, -6. Okay, so you can kind of see my x-axis and my y-axis moving in all 4 directions from the center, which is known as the origin. So let's look at each one of these possible scenarios for x that we created. Well, each one of these scenarios is actually going to be a coordinate pair. Okay, so the first one, we've got -2, +2. So I could think of that as the coordinate pair x, comma, y, where x, the input value, is -2, and y, the output value, the absolute value of -2, is a +2. So I'm going to plot this point, this coordinate pair, onto my grid here. Maybe we'll use a circle for this. Okay, so at +2, at x equals -2, over here 2 steps to the left of 0, and y equals +2, I might have a point right about here. Let me shift this just to make sure it's lined up the way I want it. There we go. So there is my point at -2, +2. Corresponds to -2 right down here on the x-axis and +2 over here on the y-axis. Okay, so I have plotted this first point, -2, +2. And what I'm going to do is I'm going to plot each of these points. So now I'm going to plot the point -1, +1. So I'm just going to take this point here and put it at -1, +1. Try to line it up pretty well. There we go. How's that? -1, +1. All right, so now I'm going to plot the next point, which is 0, 0, right? X is 0, y is 0. So I've got another point here. Let me plot. Now 0, 0, that's right here at the origin, right? So that point's going to be right there on the origin where x is 0 and y is also 0. All right, 5th point we're going to graph here. We've got +1, +1. So let's take a point and plot it at +1, +1. There we go. All right. And then finally, we've got +2, +2. So let's plot a point at, if I can get to it here. There it was. +2, +2. And that's going to be right about here. And I'm going to maybe slide this up just a hair. Okay, so hopefully what you're seeing, what you're starting to realize is that these points create kind of a V shape, like the capital letter V shape here. So we've got, if I were to connect the dots here, kind of connect the points, our graph seems to move in the downward direction when the values are negative. Once it gets to 0, it shifts and it starts moving in the upward direction, right? And this could go on forever. You know, I could find values for -3, -4, -5, -6, and I would be able to keep this going, right? In the negative direction on the left side. I could find values for +4, +5, +6, and I could keep this going in the positive direction as well. So this is the graph on the coordinate plane for the function f of x equals the absolute value of x. All right, so let's look back at our original question. We've had to go off on a number of tangents here, but the question states, in the standard xy coordinate plane, for what values of x will the graphs of f of x equals the absolute value of x and g of x equals the absolute value of x intersect? Well, here's an interesting thing about these two functions. We've got two different functions here, f of x and g of x. But the interesting thing is that they're exactly the same. They are both going to perform the absolute value of x on the input. So for both of these functions, the input is x, the output is the absolute value of x. There is no difference between these two functions. They are the same function, okay? Because they are the same function, that means they're going to have exactly the same graph on the coordinate plane. So if this is the graph of f of x right over here, then if I were to plot the graph for g of x, well, guess what? It's going to be exactly the same graph, okay? So it's going to start, it's going to come down right on top of these points, and it's going to move right back up in exactly the same method. Okay, so here I've plotted the graph g of x, and it's right on top of the graph of f of x. So the question is, for which values of x, these are your values of x, for which values of x will the graph f of x intersect or be on top of, be the same as the graph for g of x? Well, what do we think that answer is? Let's look at our answer choices. See if we can come up with something that makes sense there, okay? So let's look at our answer choices. Would it be only when x is 1? No, definitely not. Because we also know that they have exactly the same graph, exactly the same value when x is -2, -1, 0, 1, 2. They're the same graph. They always have the same value no matter what x is, right? So it's not A. It's not B. It's not only when x is 0 or 1. It's not only when x is greater than 0, or in other words, when x is positive, because they have exactly the same values even when x is negative. It's not only if x is greater than or equal to 0, meaning when x is positive and also when x is 0. Actually, it's going to be for all real numbers, okay? And the truth is, we didn't necessarily have to go into all of this explanation of absolute value and the coordinate plane and plotting points. We could have figured this out, because if you have two graphs and they're representing exactly the same function, the same operation, you take the input, you calculate the absolute value, that's your output. If it's the same machine, the same function, then guess what? It's going to have the same graph. And it's going to have the same graph no matter what x is. So in this case, f of x was absolute value of x, and g of x was absolute value of x, and they're asking, where do they intersect? It's going to be all real numbers. They intersect for all real numbers. So hopefully this has been helpful in understanding this practice problem from the HiSET FPT 6A practice test. And I hope you'll look for more problems for us in the future. I'm Andrea with Simpson County Literacy Center. Thank you.